Meet the class of 2021. If we randomly pick an organizer for this year's ceremony, how likely is it that we'll pick Ashley? And Ashley is the student right here. This is Ashley. Okay, now considering we'll be picking randomly, it means that each one of these graduates is equally as likely to be picked. So to visualize the problem, consider this square as this full space of possible picks that you can make. It means that you can't pick any place that is outside of the square. So the square is 1 because it takes up the whole probability of getting any one of the students. And Ashley just happens to be one of these equally sized subsquares. So getting Ashley, it makes sense that is 1 out of 9 because she takes up 1 out of 9 of the whole area of this equally partitioned square. If we randomly pick an organizer for this year's ceremony, how likely is it that we'll pick a male? And another question is, how likely is it that we'll pick someone whose name starts with a K? Now, since we're picking randomly, it means that each one of these individuals or graduates is equally as likely to be chosen. Now, to visualize this problem, I've drawn here a square that represents the whole area of possibility. So it's not possible to get any point outside of the square. And it's partitioned into 9 equally sized parts, each representing each student. So to calculate the area of getting each male, now let's assume the males are these 5 squares right here. Okay, so this is Max, that would be Mark, that would be Kareem, and so on. And if we're randomly picking any point in the square, getting a male will be 5 out of those 9. So it makes sense to say that the probability of getting a male is simply just adding the area of each male. And that's how you can think of these types of problems. And the other question, those whose name starts with a K, it's the same thing. You just calculate the sum of the likelihood of the students that meets the criteria of having a name that starts with a K. So that would be Kareem and Kendra. So that's just 2. So it would be 2 out of 9. The first 4 students to the right have graduated with honors. If we randomly pick an organizer for this year's ceremony, how likely is it that we'll pick a male given that we know we picked an honoree? So these 4 students are the honorees, and he told us that we know for a fact that we picked one of these. So we were only concerned is that which one of these we'll be picking. So this is kind of our new space of possibility. Okay, let me just drag this down a little bit. Okay, so now we know that we picked an honoree, and if we are to visualize this over here, let's consider the 4 in this corner to be the full space of the honorees. Okay, so it's almost like our sample space or our whole space of possibility of picking has shrank to only this square. And we wish to know what is the likelihood of getting a male given that we'll be only picking out of these 4 graduates. So now we have total 5 males as we explored earlier. Let me get this right. It's Max, Mark, Kareem, Ahmed, and Nigel. Okay, now since we know that we picked an honoree, it wouldn't make sense for us to consider Kareem, Mark, and Max. So we are only concerned with those males that meet both criteria of being male and also being an honoree. So we're only concerned with Ahmed and Nigel, which happen to make up only 2 of these squares in that full space of possibility of being an honoree. Okay, so it is obvious that this is 2 out of 4 out of the space of honorees, which is the same thing as 1/2, and you can verify this visually. It's kind of obvious. But another way, and the methodical way of going about doing it, is that you calculate the probability of those who are both male and an honoree, which is 2 out of 9, because only Ahmed and Nigel fit the bill, and you count that as a fraction out of the new kind of shrank space, which is 4 out of 9, and the 9 cancels out, so that's 2 over 4, which is 1 over 2. So if given an information that shrinks or keeps the same your space, you need to take that information into account once you calculate the fraction of that you wish to know the likelihood of. So you wish to know males, you only could have picked an honoree, so you wish to know those who are both out of those who are honoree, which is your new shrank space. The first 4 students to the right have graduated with honors, but now we wish to know that if we randomly picked an organizer for this year's ceremony, what is the likelihood of getting a graduate that is both female and a non-honoree? We considered in the last question these 4 squares to be the likelihood of getting an honoree, which is 4 out of 9, so that leaves these 5 out of the whole 9 squares to be a non-honoree. And we wish to know in this question those who are both a non-honoree and female. So the females are only Ashley and Julia. They are the only females that are non-honorees. So they take up 2 out of 5 of the 5 out of 9 it is to be a non-honoree. So to be in that whole non-honoree predicament, it's 5 out of 9 kind of the whole space. You take only 5 out of 9, the 5 out of 9 fraction, and out of that 5 out of 9 fraction, you wish to have the 2 over 5, which is the likelihood of being female given that you're a non-honoree already. So if you are in the predicament of being a non-honoree, so you're only concerned with this space, it's 2 out of 5 to be female. So that's why it makes sense that out of the whole thing, it's 5 out of 9 to be a non-honoree, and it's 2 out of 5 to be female, considering you already are a non-honoree. So that's how you solve that problem. So it should be 45 over 10, which is the same thing as 2 over 9, which you can verify visually because only Julia and Ashley. Let me get a proper shape. I don't know what shape will pop up. Yeah, it's a square. So it's 2 out of 9 to be both female and a non-honoree. Now, out of the honorees, only Lila has made her parents proud, and out of the non-honorees, both Max and Ashley have made their parents proud. So, if I told you that you'll be picking someone who didn't make his parents proud, what is the likelihood that you'll pick a non-honoree? Now, this sounds a little bit intimidating, but actually once we break this down, it's actually very simple. Now, he gave us the information that we picked someone that didn't make his parents proud. Now, those who failed their parents are distributed amongst the honorees and the non-honorees. So there's those 3, Mark, Julia, and Kareem. Those are the ones who failed their parents and are non-honorees. And you have Nigel, Kendra, and Ahmed who failed their parents and happen to be honorees. So out of these 3 out of 4, out of the probability of being an honoree, which is the same thing as we did in the question before, and we do the same for these 3 over here. But let's visualize this before we do. Now, these are the non-honorees, and 3 out of those 5 happen to be those who didn't make their parents proud. And these 3 out of those 4 are the ones who failed their parents and are honorees. So this is now the space that we know for a fact we have selected. So we can only land randomly anywhere in here. And we wish to know what is the likelihood of getting a non-honoree. So we'll only be concerned with those non-honorees that happen to have failed their parents. Okay, so these two, Max and Ashley, the ones who are non-honorees and happen to have actually made their parents proud, we exclude them. So we are only concerned with these 3. And these 3 are calculated as 3 out of 5, because that's the likelihood of being someone who failed their parents given you are a non-honoree, times the probability of being in that predicament of being a non-honoree, which is 5 out of 9. Now we wish to know that these 3, what fraction are they out of the full space of being someone who failed their parents? And we just calculated that. That would be this part, which we just calculated right here, which would be 3 over 5 times 5 over 9, plus the ones that are honorees and happen to fail their parents, which are 3 out of 4, given it's 3 out of 4 likely to be someone who failed their parents, given you are already someone who's an honoree, and to be in that whole honoree predicament, it's 4 out of 9. So it's times 4 out of 9. And this is how you calculate that. And as we can tell by the picture, 3 out of those 6, so it's 3 out of those who are both someone who are non-honorees and failed their parents, out of the whole 6 of being someone who failed their parents. So it is obvious that it's 3 over 6, which is 1 over 2. And if you actually work out and compute using this fraction that we calculated right here, you should get the same number. So to recap, that's all we did. First of all, you need to know what is your space of possibility and what is the fraction, okay, of those who meet both criteria out of that whole space. So the full space of people who failed their parents, you wish to know what fraction are those who failed their parents and are non-honorees, because as we told you, we know for a fact that we didn't pick anyone who made his parents proud, so we exclude them. So we're only concerned with the green out of this whole blue area.